Hey guys, another day, another lesson. Today we're talking about angles. In this lesson, you're going to be able to define, sketch, name, and identify angles and classify them by measure. Describe and apply the angle addition postulate. That's important. Define angle bisector and apply the definition to solve problems. Okay? So, I'd like for you to do this top section here. You're going to pause the video and we'll read it together. So this is a recall question, so it's asking you to remember information from a previous lesson. Recall rays from a common endpoint. Ray KJ, I know it's a ray because of the notation here, ray KJ and KL are not opposite rays because they did not go in the same directions to form a straight line. So, what do ray KJ and KL actually form? Take a second, jot down your thoughts. Once you finish doing that, you're going to take some notes, okay? So, we're going to define and classify angles. So, an angle is a figure formed by two rays from a common endpoint called the vertex. The symbol for an angle is this. Some people also write it like this, which is perfectly fine, but it gets confusing when you're using the greater than and less than symbol with it. So I don't do that, but if you choose to write it like that, I will not penalize you, okay? Here's a diagram of an angle. As you can see from this common point, we have a ray here, ray ML, and then ray MN, okay? So it's two rays from a common point. That common point is called the vertex, and that word should be familiar with you. In algebra, it's the highest or lowest point of a parabola. In geometry, it is the common point where both rays meet, okay, or intersect. All right, in this case, point M is the vertex. How do we write when we have a ray, or excuse me, an angle? We can call this angle angle M. So an angle can be named by its vertex. Simply, and if you want to just name the angle by its vertex, you're free to do so. You can also name this angle by the 3 points, making sure that the vertex is always in the middle. LMN, or angle LMN, is one way to name this angle, or angle NML, another way to name this angle, okay? So use the angle symbol followed by a point from each ray with the vertex in the middle. All right, then there's another note down here. Make sure you're getting everything. This note here really speaks about when you see M and the angle symbol and the name of the angle, literally means the measure. That M stands for measure, okay? So whenever you see this M, it stands for measure. The measure of angle M, okay? And angles get measured. We're going to talk about how they're measured, all right? So degrees are one unit of measure for angles. There are 360 degrees in a full rotation once around a circle. So imagine if we're going to measure this angle, it's a partial circle, the way we measure it. Okay, so we're measuring the space in between the two rays, okay? So what part of the circle is that? Well, 1 degree is 1/360th of a full rotation. This is not a full rotation. It is some part of that rotation. We don't know how much it is, but if we had a protractor, we could measure it. Classify by measure. So this should look a little familiar if you learned it in elementary or middle. There's 4 types of angles that are named by their measure. One being an acute angle. And I always think of acute angle being like literally acute angle, right? So the measure of an acute angle is always less than 90 degrees. So if you want to, this is the symbol, measure of angle A is less than 90 degrees, okay? So less than 90 degrees. If you want to write that out, cool, go ahead. A right angle is always exactly 90 degrees. An obtuse angle is actually, I'm not going to say it's between. is greater than 90 degrees, but less than 180 degrees. So greater than 90, less than 180. So it's essentially between 91 and 179. All right. And then finally, a straight angle. A perfectly straight line is exactly 180 degrees. Okay, so that's called a straight angle. That's an obtuse, a large angle, a right angle, and an acute angle. All right. So congruent angles have the same measure, and that is indicated with arc symbols. So if we're trying to say that two angles are congruent, we would do that by giving those two angles the same number of arcs, okay? Now, if you notice that one angle has two arcs and the other has one, it means that their measures are completely different. But in this case, they're going to have the same number of arcs. In this case, they both have two. That means that their measures are the same. And so this statement says angle A is congruent to angle B. And in this case, the measure of angle A is equal to the measure of angle B, because remember, we measure angles in degrees, okay? So the angles themselves, or the measures of the angles themselves, are equal because those are numbers, okay? But the angles themselves are objects, so we talk about congruency when we talk about objects, all right? So think about what we just did last lesson, and that was the segment addition postulate, which stated if we take one segment and we add it to the other, it would give us the total of the entire segment. Same thing here with the angle addition postulate. So both of these two angles are of different measures, but if I added angle PST to angle RSP, it would give me the whole thing, which is angle RST. So if I add up this angle and this angle, it would give me this whole angle here, okay? Very much like the segment addition postulate, all right? And it states that here, the measure of angle RSP plus the measure of angle PST is equal to the measure of angle RST, all righty? And finally, we're going to talk about what an angle bisector is. So remember, we talked about a segment bisector. In this case, I actually forgot to label this. Whoops, that's supposed to be a D. In this case, we're just discussing angles rather than segments, okay? So an angle bisector is a ray. A ray is, or the way it's described here, a ray is an angle bisector if and only if it divides an angle into two congruent angles. So we can call this an angle bisector if we notice that angle ABD and angle DBC have the same angle measure. And because they have the same number of arc marks, we can determine that, yeah, these are the same value. So because this ray split it into two congruent parts, this ray BD is in fact an angle bisector. So it says here, ray BD bisects angle ABC. Angle ABD is congruent to angle DBC. The measure, or the value of the measure of angle ABD is equal to the same number as the measure of angle DBC. And like I said, we use an arc symbol to indicate congruent angles. All right? You are going to go ahead and complete the try it out, all of those questions, and watch the supplemental videos. Have a wonderful evening.